Good morning, everybody. We are Group 1, and our project topic is Smart Home Automation using Smart Plug. And our teammates are Aflake, Advaitas, S. Arunap, and myself, M. Parthivan. First of all, before starting our topic, we would like to thank Dr. Matthew P. Abraham for his guidance and support throughout this project. That's why. So this is the overall view of our contents introduction, and we will be discussing about the problems and the literature and the major components, and there will be conclusion after that. And a work schedule. Next schedule. Next slide. Okay. Uh, as I told later, our topic is smart home automation using smart plug. Uh, Maybe some of you have heard of smart home automation. So basically, what is that? Uh, Let me explain that by giving you a simple example. The smart home automation is basically if you take an example, if you are in your home and you want to operate or on a certain appliances, usually we have to get it from our seat and go and turn on. That's actually we are usually doing, but in our case, in this project, we are introducing a system, a smart plug system for the automation, where you don't need to go and switch on the things. You can simply do that by using your smartphone. Everybody has smartphone. This is a modern world, and as we know that everybody, each and everybody has a smartphone. So Android smartphone. So we can use by certain applications, we can control the entire home appliances of a home. Okay. Actually, the smart plug uses a wireless home technology. It allows the owners to control, monitor, and coordinate home appliances without changing the home infrastructure. That is, without changing the entire structure, the smart plug, which is a system which we can fix in the switchboard, and we can control certain appliances. It can be implemented by four major parts. So there are four major parts. The main part is the sensor, energy sensor, which is for the measuring purpose and the sensing purpose. And the second is the microcontroller for the controlling purpose of the entire system. Then comes communication. The communication part we are using is the IoT, that is the Internet of Things. And after that, there will be a relay for the switching. Okay, with the help of a specialized sensor module, we are using a specialized sensor. We can monitor energy consumed by various devices and manage energy according, thus saving energy. So by using this system, this entire module, we can save the energy of a particular appliances of the or the entire home. Okay, next slide. Okay, problem description. Okay, there are three problems which we are discussing in this project. The first is designing a convenient system to control home appliances. That is, we are designing a smart plug for the convenience of the users, so thereby they can they can control the entire applicants by just thereby using a smartphone. Need of an accurate and effective monitoring system. Okay. Uh, there is a need for there's a need for an effective and accurate measuring system which can measure voltage, current, and power and energy at the same time, which is more important. Uh, and development of a convenient user interface Android app. So we will be developing an Android app which is user friendly, so any user can use These are without any confusion. They can clearly use without any confusion. Okay. Uh, the next slide will be the literature survey. My friend will be discussing that. Next slide.
So myself, I am Aflaid K. I will be dealing with literature survey. Through our literature survey, we were able to find two methods. That is two existing systems that is used in smart home automation. Smart home automation. There are two methods, as I said. One is design of a smart home system using Bluetooth protocol, and the other one is a system, an energy management system with the help of Zigbee protocol. So these are the two methods. So starting with the Bluetooth protocol method, it would be having two main modules. That is a hardware module and a software module. So coming to hardware module, it will be useful to interface with the peripheral devices. And in the case of software module, it will connect the communication. That is, it will communicate with the microcontroller. That is, we will be having a microcontroller, so we want to communicate with that. So this is how the architecture is divided. Then, as I said, this method of operations are taking place with the help of Bluetooth communication. That will be linking our smartphone, which will be used to control the home appliances to the microcontroller. So here also we'll be having a smartphone. Through that, we'll be controlling the devices. Here we'll be using programmable interface controllers. That is peripheral interface controllers. That can be programmed with the help of MPLABX. That is an IDE. Now we can have a look at the block diagram of the system. So as you can see, we are having sensors and Bluetooth module. Then that is connected to the PIC controller, that is PIC controller 16F1937. This is the PIC controller that we are using, or in this literature we can find. So it will be having a 5-volt power supply. Then the equipments or appliances, here we can see a gate motor, light bulb, LED light, etc. So these all are connected to relays. Through that relay, we are controlling these appliances. So we'll be sensing some, we can say that sensing temperature. So that value is processed with the help of microcontroller. Then according to that, if the temperature is high, we can switch on the fan, etc. So this kind of operation will be done with the help of sensors. And also we are having 12 volt DC supply for this appliances side, that is for operation of relay and room. And the other one is controlling the appliances with the help of smartphones. That is, these all are manual controls. There's a sensor input will be taken for automatic control. So when you are sending data from the smartphone, we require a link between the microcontroller. So we are using a Bluetooth module that will be integrated with the microcontroller. So we'll be sending them data, then that will be conveyed to the microcontroller with the help of a Bluetooth module. So these all are the basic outline of the design of the system that we have gone through. But one thing we have to note that we will be having only controlling system. There won't be any monitoring and all. So these are all we can find in this method. Now we will be moving to the other method. This will be discussed by the help of my friend Advait.
Next slide. Okay, myself Advait. So I'll be discussing about the second literature. So next slide. Second literature. Yeah, centralized intelligent home energy management system. So basically, this literature is more or less similar to what my friend Afla has already explained. So basic difference is because of the communication protocol. So earlier, the first literature what my friend has explained is basically upon the Bluetooth module. So here we are giving our priority to Zigbee transceiver module. So in this centralized intelligent home energy management system, what you're trying to do is where there is an energy management center which is embedded in a Raspberry Pi hardware, and along with an appliances, which could be there are some software parts also. And this energy management center contains a graphical user interface, which is obviously the software part, and which can even be used with an Arduino Mega, and certain systems can also be provided. But the key point in this literature that we have identified is that this literature makes use of Zigbee transceiver system. So talking about Zigbee, Zigbee is a bit old technology. So we need a transmitter, we need a receiver. So there might be some lagging, and even the cost might not be very favorable. So, and the status of appliances is checked by measuring the voltage and current of the appliances, depending upon this system that we have conducted our literature survey. And the energy management system is deployed on a Raspberry Pi microprocessor. On talking about the Raspberry Pi microprocessor, such a highly powerful processor might not be required for such a small operation. So even we could consider that the Raspberry Pi is a highly powerful processor, which can even be, which can process highly complex data, but we only need some small processing power. So this is a waste of waste of power, or even there might be some losses, and even the cost. On considering the cost also, this is a huge disadvantage. So next slide, please. So on summing up about the two literatures so that we have identified, so we could easily say that the smart home systems currently play an important role in ensuring high quality of life. We can view the stats of our home environment and control our home appliances. So that is the primary objective of our project. So the rapid development of embedded systems, including both hardware and software, has made these systems easier to implement and more flexible, leading to lower costs. So we could implement a simple hardware and even a more user-friendly software. So both mobile technology and appliances have rapidly increased in the recent years. So most people are addicted to mobile phones. So we'll be developing an application using mobile phones might be. So this idea might be really good. So in terms of user interface and applicability. So most people cannot work or conduct their daily tasks without mobile phones, since we designing our proposed system running on mobile devices, as we said earlier. Furthermore, we are also thought of integrating a cloud platform and a database in the form of a web service to enable flexible and extensive scalability to heterogeneous systems in the future. So what we're trying to do is we'll be integrating our whole system with a cloud database management system, in which the whole data from the sensors will be sent to the cloud platform, and where the computations will take place in the cloud platforms, and the results are directly sent to the Android mobile phone platforms. So coming to the last part of our literature survey. So next slide. So my friend will be explaining about this slide.
So coming to some more conclusion of the literature, what we come to know that is we require a system or a module which can easily and conveniently measure the power, voltage, current, etc. So that should be accurate also. What we are lacking is the monitoring in both the literatures. The monitoring applications are not that much included in many literatures. They always say about control of the devices. So we require an efficient method to monitor the power, the voltage, current, etc. And coming to communication technology, that is Bluetooth, Zigbee, etc., much more slower and less efficient compared to Wi-Fi. So going with Wi-Fi is always best in this era. We are having pretty much good connectivity with the help of Wi-Fi. So we want to go with the help of Wi-Fi technology. And coming to the controller side or developer goal, we should focus on the cost, because we require very, what to say, somewhere very low cost or low processing speeds and all. So we don't require a very costly Raspberry Pi or other things, and we want to reduce the number of modules. If we are using a big microcontroller or other microcontrollers, we will be having a need of another module to like Bluetooth module, so we have to communicate. So in the case, if you are able to develop a board with a or able to find a board with both microcontroller and Wi-Fi module, so it will be great. So we are also looking into that. So these things we could conclude with the help of this literature survey. Next is our methodology. So that will be taken with by my friend Aruna. So
Yeah, so myself, I am yes Aruna. So next slide. So let us discuss in details about our solution to the problem. So this is the basic block diagram of our project. So we have included this block diagram because, as you can see, by looking at this block diagram, it is easy for you to understand the process. Actually, we will discuss in details about each and every components. But first of all, let me give a brief idea about the overall process that is taking place. So as you can see in this block diagram, the data from the PSDM0040, which is our energy sensor, is coming to the microcontroller. So the microcontroller we are using is a Node MCU microcontroller, which has an inbuilt Wi-Fi module. So this data can be analyzed by the microcontroller, and also it can be sent by the microcontroller to the communication part. So the communication part is where the IoT is coming. So as you can see in the diagram, the data from the microcontroller is going to the communication part. That is, it is storing the data in a cloud database. And also the microcontroller can retrieve this data from this database. And whenever our app mobile is connected to the Wi-Fi, it can access the database. So as in the diagram, you can see that the microcontroller can also send signal to the relay. So actually, this is the basic operation that is taking place in the microcontroller. The operation that is taking place in our project. Next slide. Yeah, so these are the things I have explained now. Just you can just go through this point for 1 minute, and my friend Afla will discuss about the circuit diagram.
so coming to the connection diagram, first we have to have a look at what are the modules. As Arnab said, we are having relay sensor module that is PZ0040. Then developer board that is not MCU, it's a microcontroller, inbuilt Wi-Fi is also there. So then we'll be having a dual converter for providing DC voltage for relay and all. So this is the basic outline. Now starting with the line that is we are having two supply that is line and meter. So starting with line, the line will be given to first put into the relay. So either we can use normally or normally cost, that is the and we have to use line will be connected to the common, then that is taken out either from normally open or normally closed. Then that will be given to the PZDM. So then the neutral will directly go into the PZDM. This is how the connections is given to PZDM. Till now we are given our supply to the PZDM. Then then we will be taking two lines, that is line and neutral from PZDM, that is given to the load. So whenever the relay is when you set the relay or trigger the relay, then only we'll be having connection to the load. And we can use a 230 volt 5 and 3.3 volt converter. The 5 volt is meant for relay, that is VCC, and then will be there. Then we can have 3.3 volt, that is for a node MCU. Coming to again the PZDM 0040, that is there will be having 4 pins, that is including 5 volt ground, so that is for basic power supply. Then we'll be having RX and TX, that is with communication there. Here we will be using UART, that is Universal Asynchronous Receiving Transmitter Communication Protocol. Then coming to communication or interaction with the cloud, we'll be sending data to the cloud through Wi-Fi module, which is inbuilt, and then that way we can have a look at how interaction with the smartphones and all. So this is how a basic connection diagram look like. Now we can have a look at the PZDM0040 power sensor. So coming to that, we will be having a figure on the slide, that is physical figure is also given, as well as will be having functional block diagram. So in this figure, we can clearly see that what all are the inputs or how the line and neutral connected to the sensor. So we'll be having 4 pins in the high voltage side, that is line, neutral. Then that line and neutral will be taken out and go to the load. Coming to the lower side, that is we'll be having signal pins, that is 5 volt and ground. Then we'll be having communication pins, RX, TX. When you look at the functional block diagram, we'll be having a measurement system. Then optocoupler isolator will be there to separate between the high power side and low power side. Here, how it works, it is actually we are having only 2 pins for communication. It will be working based on a TTL interface. We are having different memory sets for whatever are the measured values stored. So the task is that we have to access all those locations, whatever needed. If you want current voltage, so current will be having a most significant bit and all. So higher order bit and lower order bit. So it will be stored in some locations that all are available in the data sheet. So we can have a look at the memory locations. And the task is that we have to process that data using code with the help of Node MCU. That is how the communication and risk process will be taking place. Now moving to some more points that related to PZDM 0040. In our literature survey, we were trying to say that we require a convenient, accurate method to monitor the power. This is how we wish to solve that issue. We are having a sensor module with an accuracy of 0.5 percentage. PZDM 0040 is available in 2 variants, that is, we'll be having a 10 ampere variant and 100 ampere variant. For our purpose, that is for home automation, we require only 10 ampere rated sensor. So we'll be going with that variant. As I said, the communication and measuring takes place in that way. Here we can have values of power, voltage, current, energy, power factor, etc. So these all are about PZDM 0040. Now we can have a look at the node MCU and so it will be discussed by my friends.
Yeah, so let's discuss about this Node MCU. So the microcontroller we are using here is Node MCU microcontroller. So actually this Node MCU is similar to that of Arduino microcontroller. It is actually the modified version of Arduino microcontroller. The code that we are using in Node MCU is same as that we are using in the Arduino. The specialty is that the Node MCU has an inbuilt ESP8266 Wi-Fi module in it. And so as you can see, in Node MCU, there are 9 digital pins. and one analog pin. And as you can see in the left side, D0 to D8 are the digital pin, digital IO pin. You can use it as input or output. And we are having A0, which is the analog input pin we are having. Also, you can see other pins like for the supply voltage. It's operate on the voltage of 3.3 volts. You can see various ground pins and TX and RX pins for the communication parts and all. And this Node MC will be having a CP2102 USB to UART converter. So why we are using it? This is that our laptop, it is a USB protocol, and our Node MC will be working on UART protocol. So there is a need for conversion from USB to UART. Then only we can upload code into it. So that's why we are using this converter. Actually, we don't need to go that much deep into it. So if you know how all these pins and how you can connect various devices into Node MCU, and if you know the coding very well, is it easy for you to implement this? Next slide. Yeah, so these are things I have said from now. As you can see, Node MC is compared to Arduino, it has an inbuilt Wi-Fi module, and also it is small in size compared to Arduino microcontroller. And considering cost, also it is very low compared to this Arduino. So next slide. Yeah, so coming to the next part, which is the communication part or the IoT part. Actually, this IoT part consists of mainly three things: ThinkSpeak Cloud platform, Wi-Fi, and Node MCU. As you can see, the data from the sensor is coming to the Node MCU, and we need to send this data to a cloud platform or store it in a database. For that, we are using ThinkSpeak platform because it is a well-professional one, and it is also a user-friendly one, which has a wide range of applications in it. So, so the data is coming to the ThinkSpeak platform, and we can analyze the data in the ThinkSpeak platform. So, consider ThinkSpeak. Actually, we can create a channel in the ThinkSpeak. So, all the data from the sensor will be uploaded in the ThinkSpeak. So, next slide. So, as you can see, this is the basic screenshot of a channel we have created. And this graph is based on the data we have entered manually. We have shown this graph because you will get an idea about how it looks like. So if you get the data from the sensor, you can plot, it will be showing like a plotted graph like this. Actually, there are a lot of other options available in the widget area where you can, if you want, you can show it in a numerical way also. So this ThinkSpeak is a great platform for analyzation. And another use of it is that it can be also used for reaction. So what this reaction is that, actually I will tell you by example. So suppose that our power consumption exceeds a certain value, we can just trigger a reaction. That is one of the options of this ThinkSpeak. So what is actually this triggering reaction is that this reaction will be consisting of a website or a web URL, which will be connected to the IFTTT platform. So what is this IFTTT platform is that, actually with the help of this IFTTT platform, it has a lot of features like you can connect Google Assistant and Gmail to it. So for example, if as I said, if the temperature exceeds a certain value, you can send a notification to your email saying that the power consumption has exceeded a certain value. And another advantage is that you can also connect Google Assistant to it. Actually, there's a lot of features. So if you are connecting Google Assistant, you can just say to your Google Assistant to turn on the light, and that signal through IFTTT will be coming to this ThinkSpeak, and you can control the relay accordingly. So actually, you will be understand the wide range of applications into it. So in this way, you can do a lot of things in ThinkSpeak platform. And as I have said, the data from the node MCU comes to the ThingSpeak, and it can be used for analyzation, reaction, and also to give notification. And one more interesting thing is that all this data that is shown in the ThingSpeak can be sent in the Android platform also. So my friend will explain it in details about how we all these things about Android platform, and he will show you by the app made by him. So as far as the IoT part, this much of things you need to learn. That is the data from the Node MCU coming to the ThingSpeak platform, and we can analyze it, react it, and also send notification. And actually, there's a controlled way. That is, we can selectively give information to the Node MCU to ThingSpeak platform, and also from there we can send it to the Android platform. So that's all about ThingSpeak. My friend Advait will explain about the application or Android platform.
So next slide, please. So the concept about application development is that basically, so the data from the cloud should be fetched to the application. So that might be our that should be our primary objective. So the data from this electrical device is taken into the PZDM module, then to the node MCU, then to the cloud. So this data can be fetched with the help of certain protocols that is provided in the ThingSpeak platform. So we can easily take this data into our Android application and display it in the form of certain activities. So a basic UI front-end application has been developed. So I will be showing you the figures. Could you please go to the next slide? So this is just the demo of the UI for the front-end application that we have developed. So in this application, there are 4 switches in which we could easily turn on and off these devices using these switches, and there are 1, 2, 3, 4, 5 buttons. So when we click this device 1, we can see the insights about these devices. That is the voltage, the current, the power factor, and even the energy consumption. So all these data coming from the cloud has to be displayed in this application. So all these can be easily done with the help of the ThingSpeak cloud platform. Even though we should know the fact that ThingSpeak is a part of MATLAB, even it is supported by the MATLAB. So we could easily provide some graphs and technical data with ease. And previous slide, please. So with further modifications, we can even integrate Google Assistant to take voice commands and turn on and off the devices. So even we could integrate Siri, Alexa, Google Assistant, or anything. So these are all just software integrations. So as far as the software part is concerned, the scope of this project is to its extreme. So we could integrate even a machine learning algorithm, such as we could even predict the load scheduling. We could even do some machine learning or even some AI algorithms to do some future technologies. So as far as the software is concerned, anything can be upgraded. So this is a very flexible project. So next slide, please. Next slide. Okay, so this will be explained by my friend.
So for the switching purposes, we are using a 5-volt relay. It is basically an electromechanical relay. The operation of it consists of 2 conditions or 2 stages. That is normally open and normally closed NC. So in normally open, the circuit will be in open stage and it becomes closed whenever a high value of input comes. So when we give a signal, it will be closed and the current will not be flow. And the second stage is NC, that is normally closed. In NC, the normally closed circuit, the circuit will be normally closed and it becomes open when a high value of int comes. So when we give a signal, it opens. So it is normally in a closed position. When we give a signal, it opens. So this is a figure of the relay we are using. So you can see there are 6 pins in there. You can see NC. NC is normally closed, C is common, and NO is normally open. And below bottom you can see 3 pins. One is ground, one second is VCC, and signal. We can keep the signal is coming from the microcontroller. Here we are giving the signal, and by we are opening the 2 stages. Next slide, please. Okay, let me come to the conclusion. Okay, so in this our proposed model, we came to so many new terms. So these terms, too many terms. So here in basically, we are trying to implement an extensive and novel architecture for a flexible, low-cost home control and monitoring system. For the low-cost home control system, we are proposing a new model. It is based on Android OS that allows the users to manipulate and control the home appliances. The proposed system as a sensing module, PCD module, which has certain capabilities, control and monitoring capabilities such as voltage. You can measure voltage, current, power, factor, frequency, etc., and which are sufficient to demonstrate its feasibility and effectiveness. Next slide, please. So the smart home system as a major can play a major role in ensuring a high quality of life or standard of life, which can impact in our lives. And a smart home system consists of a subsystem. So it is basically a subsystem on Internet of Things technology. So it is basically Internet of Technology things that are suitable for various purposes such as surveillance, intruder control, and redetection. So you can detect intruders, and you can use for surveillance purposes, etc. So the proposed system can be implemented using smart devices like smart plugs, switch boards, etc. So you can use the smart plugs, or the proposed system can be used in smart plugs or the switch boards. We can integrate these things, that way we can use these things. So as far as the markets are concerned, the market demand for the power proposed system would be very high. As in the modern world, it has the ability to solve a number of problems, like it saves energy, electricity bills, provides security, user-friendly, controlling, etc. So these are some main features of this proposed system. So in this small and well, as we can see that how it is important in our daily lives, and how it can impact in our life, day-to-day life, and how it can improve our quality of life, etc. So the next is the work we are done till, which will be explained by my friend Advait.
So my friends have already explained our whole project. So we'll be discussing about the work schedule and how we'll be completing. So the idea or the plan of ourselves completing this project. So we started our project in October, and the idea formation and the literature survey were done during this time. And in the early November, we started making the methodologies and the design for the system. And at the late stages of the November, we have developed an Android application. That is the basic front-end development has been completed. So as of now, and coming to December, so we'll be doing researches and internships on IoT, and we'll be specializing ourselves on PCBM modules and Node MCUs and all those things. And coming to the January, so we'll be focusing upon the hardware part, hardware implementation and testing. Then February will be focusing upon the software part. So basically what we're trying to do is analyzation and reaction of data using ThingSpeak and notification using IFTT. So February will be fully dedicated for the software development part. And even though March also will be using some backend development for the Android application. And finally, April, final testing and prototype submission for our complete project. So that's all about our work schedule. Next slide. So these are our references. So most of these are the references which we have mentioned in our literature survey and part of our methodologies. Next slide, please. Continuation of our references. Next slide. Thank you. So that's all about our project.